Hi everyone, today's lesson is on sinusoidal applications. We're basically going to apply everything that we know into a sinusoid graph. And so let's get started. All right. So first one that we're going to start with is a sinusoidal curve. Has a high point of 1,7 and a low point of 6, -1. So what they're doing is they're giving us some key information right now. This right here being a high point. This right here telling me it's a low point. So I'm going to graph my sinusoid, okay? And let me try to make that a little better. So I'm going to graph my sinusoid first, 1,7. So I'm going to go over 1, up 7. So here's this point right here. And so there's 1,7. There's my high point. And I have a low point of 6, -1. So we'll say this is 6 here. And then -1 is here. So that value is 6, -1. So the trick here is, I'm going to put that on the side. Okay, so here's 6, -1, is this. Your sinusoid, is going to go with a curve. Of course, we're going to connect the 2 points, but there's a curve in between. So basically, it is going to look something like this. It's going to go up, come down, and look like that. What you need to remember is what's happening here. What kind of a graph does this look like? Maybe is it a sine wave? Is it a cosine wave? Let's review for just a minute. A sine wave starts at 0, picks up, goes down, -1, up 1, down 1, ends at 0. A cosine wave does this. Starts high, so up here, comes down, comes back up, ends high. Starts high, ends high. So what you have, if I'm looking at this correctly, is this part of the graph. You've got from here to here. See how you've got like that part of that graph? So, obviously a sine wave is a cosine wave shifted across horizontally by pi over 2. But if you were to make this a cosine wave, this is what you have from here to here. Okay, so that is a cosine wave right here. But what you do also need to realize is that you have half of a cosine wave, meaning the other half of my cosine wave is going to do this. All right, so what you have is half. And this distance from here to here, 6 - 1, that distance from here to here is 5. That means that the period for my graph, okay, the period for my sine wave is 5 + 5, which is a total of 10. Okay, so I'm going to erase this here and put my VAF. Now, for those of you who have been watching the videos, we use this sort of a mnemonic called VAF. So VAFHP, and that stands for vertical shift, amplitude, frequency, horizontal shift, and period. So if I were to put my graph like this, y equals vertical shift plus amplitude, time, we're going to make this a cosine wave, frequency times x minus h. And p is not on there. P is like in this area. So we actually know the period is 10. So this is 10. Now, in order to find the vertical shift, you're going to find the average of your high and low point. Average means you add them up, divide by 2. So we're going to go 7 plus -1 divided by 2. So that's going to be 6 divided by 2, which is 3. So at right here, 3, I have a value right here. That's my new axis, okay? So that my amplitude is this distance here. That's the height of my sine wave or cosine wave from my axis. So I'm going to go, it's always a length. So it's 7 - 3. And what is that? 4. So 4. So my amplitude's 4. My vertical shift is 3. We do this last, by the way, okay? We'll do that last. Horizontal shift. Have I moved my graph left or right? And it looks like I've moved my graph over. It shifts over to 1. So this means that here at right 1, okay, that's my horizontal shift. Now, lastly, I'm going to look for my frequency. Now, the frequency of my graph is basically based off of my period. What you need to remember is that the period is equal to 2 pi over your frequency. We don't know the frequency, but we do know the period. So I'm going to go 10 is equal to 2 pi divided by my frequency. I'm going to cross multiply. I've got 10 times my frequency equals 2 pi my frequency equals 2 pi divided by 10, which then makes pi over 5. So my frequency is pi over 5. Cool. So now we have all the ingredients for our graph. And so my final graph is going to be y equals my vertical shift, which is 3, plus my amplitude, which is 4, cosine frequency, pi over 5, times the quantity, x, if I'm going to the right, minus 1. So here's my new sinusoid equation. See, that really helps. All right, next problem. Oh, that's the same problem. Application problems. The water level in the Boston Harbor rises to a height of 12 feet at a high tide. So that's important because it's a high tide. Okay, let me move this up a little bit because I'm losing my bottom value. And falls to a height of 3 feet at low tide. This occurs between 8 a.m. and 8 p.m. So let's make a graph. And if you want it, I would suggest even stopping the video, trying to do the problem yourself, and then coming back and working through the problem. Okay, so anyway, I'm going to write the VAF, V, A, F, H, and P. So we've got vertical shift. So the water level, let's see here, has a height of 12. So up here is 12. And my low tide is 3 feet. It says that happens between 8 a.m. and 8 p.m. Okay. So it looks like high point again. So this is, high point and a low point. So again, anytime they give you a high point and a low point, it's always going to be a cosine because your cosine starts high, ends high. What you have here is half of your graph, just like we were talking about in the last problem. See, this is going to keep going on like that, okay? But you at least have half of your period, and you know that from here to here, from 8 a.m. to 8 p.m., how much time is that? So what you've got is your vertical shift, frequency, horizontal shift. You've got your period, okay? So when you're doing this, let's see here. So we know that this is what? Line going across my top. We're going to cut this in half for my vertical shift. We're going to add these up, okay? You're going to go parenthesis. You're going to go 12. Let's see here. Plus 3 divided by 2. 15 halves, so that's 15 halves. So my vertical shift is 7.5, okay? So hold that thought. All right. We're going to try to figure out the amplitude. So if this value right here is 7.5 here, because that's the difference between, or the average of 12 plus 3 divided by 2, we've got to figure out this distance from 12 to 7.5, because that's your actual height. So we're going to take the absolute value of 12 and subtract 7.5. And what's that? 4.5. Okay, so that's going to be 4.5, 7, 8, 9, 10, 11, 4.5, amplitude. Okay, frequency is last, horizontal shift. It looks like I've gone over 8 in my time, this is time. So I've gone over 8 hours. So this is going to be right 8 hours. And we know the period. So from 8 a.m. to 8 p.m. is 12 hours. Remember, that has to double. So if that's 12 and that's 12, my period is going to be 24 hours. So in order to find the frequency, you set up your equation, okay? Period is equal to 2 pi over frequency. Your period is 24, so that equals 2 pi divided by my frequency. I'm going to cross multiply. 24 times my frequency is equal to 2 pi. I'm going to divide both sides by 24, and I'm going to get, let's see, what am I going to get? Frequency equals pi over 12. So this is pi over 12. So if I'm writing my VAF, so I'm going to go y equals v plus a cosine, starts high, ends high, frequency times x minus h. My equation is going to be y equals my vertical shift 7.5 plus my amplitude 4.5 cosine. My frequency is pi over 12 times the quantity x minus 8. All right, cool. That's my equation. All right, so the next question is based on, the Ferris wheel problem. Okay, so for this problem, a Ferris wheel has a radius of 20. So keep in mind, when they start talking about a radius, that's your radius here. We've got a Ferris wheel, that's my radius. My radius is 20. It rotates once every 40 seconds. So that means that 40 seconds is now what? My period? Yeah. So we've got V, A, F, H, P. My period is 40. Okay. Vertical shift, amplitude. Okay. So what else do we know? We know that the passengers get on 1 meter above level. Okay, so let's draw a graph and see what this looks like, because we know that the actual diameter of my Ferris wheel is actually 40. So the length is 40. So if I start above 1 meter up, then that's going to be 40 up from that. And so that's going to be ending at 41. So I need to know what this length is here. So my vertical shift. So again, find the average. So you're going to go 41 plus 1 divided by 2. So that's 42 divided by 2. So my vertical shift is 21. Now, that means that this line that fits right in the middle is 21. So then the distance between here and here, right? Because it looks like I'm going to start, I don't know where I'm starting yet, but I know my amplitude is going to be between 41 and 21, so that's 20, okay? Now, let's think about this. You don't get on at the top of the Ferris wheel. You got to get on at the bottom. So my guess is because you're getting on at 1 meter above, as they said, you're actually starting at ground level. It's going to go up and come back down. Okay, so to me, this actually looks like a negative cosine graph, okay, because it starts low, ends low. So, okay, so that being said, what do we want to do now? We know that the vertical shift's 21. We know that the amplitude is 20. Frequency is last. Horizontal shift, there is none because we're starting here at 0. Time is 0. The Ferris wheel is not moving as you're getting on, so it's 0. So period is equal to 2 pi over the frequency. My period's 40, so I'm going to go 40 is equal to 2 pi over my frequency. I'm going to cross multiply. I get 40 times my frequency equals 2 pi. My frequency equals 2 pi divided by 40, which is pi divided by 20. So my frequency is pi over 20. So putting in my VAF, so y is equal to my vertical shift, which is 21, plus my amplitude. This is a negative cosine graph, so hold everything. Boom. This has to be minus 20, because 20 is my amplitude, and amplitudes are always positive. This value, because they're lengths, this negative here is just telling me if it's a negative or positive graph. It's not attached to my amplitude. Amplitude's always positive. Okay, so now we have cosine, because it's a negative cosine. What's my frequency? Pi over 20 times, do I have a shift? No. So it's not, I could write x minus 0, or I could just write x. Okay, cool. Now, it did say write your expression as a function of time and height. So, I mean, realistically, I could say h for height is equal to 21 minus 20, let's see here, cosine of pi over 20 t for time. Because, I mean, realistically, on the test, or, for an assessment, you're going to be asked like to plug time in. Like, let's say 5 seconds go by. Where are you? And so you would need to plug 5 in for time, like right here. And then you would work this out on your calculator because you're using pi and multiplying cosine, unless you know those values in your head. All right. Okay, so next. Okay, so where we're at now is we're talking about, this next problem. And this next problem talks about a water wheel. And it looks like, I don't know if you've ever seen a water wheel, but they do have these at, I don't know, Disneyland and whatever. They use them for, you can make electricity, but mostly you use them on like the old boats and they make you go forward or backwards. So this water wheel has a radius of 7. So that means that my wheel is actually going underwater 1 foot. Okay, so let's make our graph. And again, it's always, I always encourage you to turn the video off, start practice, try to get as much information as you can, and then turn it back on and do the problem yourself. But that being said, let's move forward. The water wheel in the figure rotates 6 revolutions per minute. So what's 1 period? A minute, 60 seconds. 6 revolutions, 60 divided by 6. So our period is every 10 seconds. We have a revolution. So you start your stopwatch. 2 seconds later, point P is on the rim as at the greatest height. So that means that you start your stopwatch, go. 2 seconds later, here's time, okay? Here's 2, we're up here, way up here. You are to model the distance to the point, the surface. Okay, I'm missing something. It means that my graph actually has to go down below and then come back up. All right, so basically what we have here is this value here, because right here, see this is -1. All right, so there's -1. It starts at 2. My period's 10 seconds, so that means it's going to end at 12. So this distance here is 10 seconds. Let's write our VAF. So VAFHP. So my vertical shift, again, to find the vertical shift, you take the average of your high and low. So that's going to be 10 plus -1 divided by 2. 9 halves, which is 4.5. That's my vertical shift. So at 4.5, there we are, right there. That value right there is my vertical shift. Okay, so if my vertical shift is 4.5, that means that my amplitude is going to be subtracted from that. So we're going to say, what was my high point? What was my high value? Dun, dun, dun. Great. It's at the greatest height, P. Okay, so vertical shift, this was 10. That's not right. -1. Suppose that your water wheel rotates 6 revolutions per minute. You start your stopwatch 2 seconds later, point P. See, this can't be 10. Let's erase that. I think I wrote that. That was my period, and I put that in a bad spot. Let me move this here. That is my period. Okay, that's a bad spot because what my height is not 10, if you recall. It does go down -1, check, correct. But remember, my radius was 7, which means my diameter is 14, 7 and 7. So that means that the whole diameter is 14, so my high spot is actually 13. Okay, whew. All right, so that means 13 plus 1 is 14, and we're happy. Happy campers. So here we go. Not 4.5. Let's erase that thing. Let's get the right answer. So we're going to go 13 plus -1 divided by 2. So 13 minus 1 is 12. 12 divided by 2 is 6. So my vertical shift is 6. So then this distance right here is my amplitude, okay? So amplitude, absolute value of 13 minus 6, which is 7. Frequency is last. Horizontal shift, I shifted over to the right 2, so that's going to be right 2. My frequency, remember how to find the frequency, use your period. So my period is 2 pi over my frequency. I know my period's 10. So 10 equals 2 pi divided by my frequency. I'm going to cross multiply. 10 times my frequency equals 2 pi. My frequency equals 2 pi divided by 10, which is pi over 5. So that's pi divided by 5. Okay, so what we do now is we put our VAF together. So we go y equals my vertical shift. So remember, y equals v plus a cosine or sine, depending on if it's cosine or sine. I mean, it would be sine if it said starting at 0, positive, moving up, positive, etc. But these all say starting at the high, ending at the height, that's cosine. So vertical shift plus amplitude cosine frequency, x minus h. Okay, so that's the form I'm putting it in. So vertical shift is 6 plus 7. Cosine frequency, which is pi over 5, times the quantity x minus 2. And again, they want you to make this as a function of time. If I want to make this as a function of time, that would be t right here, okay? Now, they did say that, I think, somewhere, write the equation in terms of sine. So that seems very fair. Let's just try to make this in terms of sine also. So in order to do that, we need to figure out sine. I can either make this a negative sine wave starting here or a positive sine wave starting here. But in between here, let's try to think about this. What's the middle mark? Because that's going to give me a halfway point. So I'm going to go 2 plus 12 divided by 2. So that's 14 divided by 2 is 7. This value is 7, okay? And then I would say, well, what's in between here and here? Well, from here to here, I would say, well, I'm going to have to go 7 plus 12 divided by 2. So what's that, 19? I can also go 7 plus 2 divided by 2. What's that, 9? 9 halves. What's 9 halves? That's 4.5. So that means that if I traveled right here, this right here is 4.5. Okay. So if I wanted to make that a negative sine wave, okay, and I'm going to erase this so I have a little bit of room. If I wanted to make that a negative sine wave, I would go like this. Y equals, this is the same, 6, but because it's negative, that becomes minus. All these values are the same, sine pi over 5 times. Now, this is going to be x minus 4.5. Okay? All right. Okay. Researchers find a creature from an alien planet. Its body temperature varies sinusoidally with time. 35 minutes after they start timing it. Okay, let's start making a graph because they're giving us all kinds of really cool information, and we need to write that down as we're going. Okay? All right, here we go. Its body temperature varies sinusoidally with time. There's a little alien. 35 minutes after they start timing. Okay, very important. 35 minutes, right there. It reaches a high point of 120 degrees. So here we are, super high, 120 degrees. Here's time in minutes. So here we are at our high point. 20 minutes after, we get a low point. So 20, if I add 20 to 35, now I'm at 55, okay? And I'm at a low point. So what they've just done is they've just showed me this value here. Okay, I can do better than that. And I will. Where's my low point? Here's my low point. What was my low point? 140 degrees, 104. We have a low point, and it's going to look like that. So I'm going to write the VAF out. So we're going to go V, A, F, H, P. Vertical shift. I have to find the vertical shift is my average from my high and my low. So I'm going to go 120 plus 104 divided by 2. And so that's going to be what? 224? 224 divided by 2, which is 112. So my vertical shift is 112. That means that right here, I have a vertical shift of 112. So that 112 is my vertical shift. And that's my new sinusoid, so T prime. To find my amplitude, it's the absolute value of this distance right here. So we're going to go 120 minus 112, 8. Okay, so there's my amplitude. My frequency is last, okay, horizontal shift over right 35. And my period, so what I know is that the distance from here and here is 20 minutes, okay? But as you know, that's only part of my graph. My graph still has to end high, being cosine. Starts high, ends high. So therefore, 20 plus 20 is 40 minutes. Okay, so my period is 40 minutes. So that means that my period equals 2 pi divided by my frequency. My period is 40, so we're going to go 40 is equal to 2 pi divided by my frequency. I'm going to cross multiply. I get 40 times my frequency equals 2 pi. My frequency equals 2 pi divided by 40. So therefore, pi over 20 is my frequency. So that goes right here. So therefore, my new equation, all right, is going to be y equals, plug in your VAF, vertical shift, 112. It's a positive cosine, so plus 8. Is that an 8? Yeah, 8. 8 cosine frequency, pi over 20 times horizontal shift, x minus 35. So x minus 35. Okay? All right, super cool. Now that's my equation, but this is a question here that I didn't answer yet. And this question basically says, what was the temperature when they first started timing? So I'm looking for this number. Oops. I'm looking for this number right here. Where did I cross my x, or excuse me, that's my y. Where did I cross my y-axis? That's the big question, okay? And in order to do that, remember this is time minus 35. I'm going to move that over a little bit. Move. Because I'm going to rewrite that so you can see it better. Okay, let's try this again. Delete. This says t, what was my shift? Minus 35. Okay, so right here to answer this problem, okay, you would plug in 0. So you would say 0 minus 35, negative 35. And you either would plug this in your calculator or you would just, like the TI Inspires, you just plug the entire thing in. Be very careful when you do that because you need to be in radians. Otherwise, you'll get an incorrect answer. So you're going to go 0 minus 35, that's negative 35. You're going to times pi over 20, take cosine of that answer, times that by 8, add 112, and then you're going to get this value here. I have a feeling that the answer, I want to say it's like 112. I don't remember the actual answer, but you can plug that in and get that. Okay. I think it is 112. So I'm going to write that down. Oh, uh-oh. I don't know what just happened. Oh, there we go. So I think by plugging that value in, y equals 112, this is when t equals 0, because that's what I'm looking for. When did it start? Let's see, 112 plus 8 cosine pi over 20 times negative 35. I believe that number is 112. And so that means that equals y. At 112 degrees, that's when it actually started. There's another question here that talks about the bouncing spring problem. I really like this problem. But I think that this would be a good time for you to try one of these problems yourself and see how that goes. And so I'm going to let you do that. And then once you have this answer, I'm going to move to the next screen and then you can check your answers. So there you go. So hopefully you checked your answers. you have this, and the actual, you can freeze this because I'm going to move on. The next video that we're going to be doing is sinusoidal regression. You will need a calculator for this, so when you do watch that the next time. Okay, so watch out for that video for the next time. Again, this is the bouncing spring problem. Check your answers. You do need a calculator because you are plugging some values in after you find your equation. Okay, so I really hope this helps you, and thanks for watching. And let me know if you like these videos. I appreciate that. Okay, thank you.